Hi, welcome to the first talk. My name's Karl Jones. I'm going to be talking about the particle system, some of its upcoming features, and some tips and tricks for performance. Okay, so who here uses the particle system? Put your hand up. A few people. That's useful for you then. And who's an artist? Who's a programmer? Is there any programmer? Okay, so it's a good mix because I've got some programming tips. I wouldn't want to give them all to artists. My name's Karl. I'm part of the sustained engineering team. So we are responsible for what's called the patch releases and supporting the stable versions, the long-term support. But I'm also a member of the particles and localization teams. And today I'm going to be talking as part of the particles team. So just a quick check. How many of you are still using the legacy particle system? Hopefully none of you. Because the first thing I'm going to talk about is the removal of a feature. It's gone. In 2018.3, it'll be completely gone, and you won't be able to use legacy particles anymore. We have got a upgrader tool that we've been continuously supporting at the moment, and that's available on the forum at that link. So if you do have any issues upgrading your effects, just let us know through the forum and we can help you work through them. It doesn't support script updates, I'm afraid, but we can help you with any issues if you do have any. So onto the first feature. What we're currently calling the ring buffer, we will probably rename this feature because it's more of a programmer name than an artist-friendly one. So currently in the particles, you have what's called the maximum number of particles. So internally, that's what we call the buffer. So if you were to say, I want 100 is my maximum particles, internally we'd have a buffer or kind of a list for 100 particles. And once you fill that list, so every time you're spawning a particle, once that list is full of 100 particles, you can no longer spawn any more particles, and so it just stops creating any more. So in this new feature, we now allow you to remove the old particles and replace them with new ones, so you can prioritize them. So here's a little example. Here we have the default approach, so we have a little footstep effect behind it, and you can see as it gets full, and this little bar indicates the buffer, we no longer spawn any more particles until new ones are available. So in the new mode, we have two different ways of it working. We have what's called pause until replaced and loop until replaced. So pause until replaced will replace the old particles with new ones and immediately kill the old ones. So that will maintain your maximum particle count. And this lets you to create sort of nice decal effects and keep spawning new particles while still maintaining that limit that you want to apply, which you might use for performance reasons or for your effect. And as you can see here, it just creates the new ones. When this mode is enabled, you will constantly maintain that maximum particle count, so old particles aren't removed anymore, they're paused. So it will play the lifetime and then pause at the very end. So in this instance, we fade them out, so you can't see them, but they are still present. And we have another mode, what's called loop until replaced. So this allows you to be a bit more artistic. Instead of having a harsh removal of the particle, you can apply an animation at the end. So I'll just show you. So when it's full, we still continue to spawn particles, but we remove the old ones, and you get that nice fade. But what that does mean is that you will have more particles than your maximum count, so it will go over, and then over time it will restore itself back down. So if you have particle effects that have very long lifetimes, then you need to be aware of that because you will go over your maximum particle amount and it can go quite high if you have a lot of them. But it does allow you to apply more animations. So in this mode, we allow you to set a loop point between 0 and 1, and it will continue to loop through that point whilst the particles are still alive. When they're removed, it will then pick the end of the loop. So for example, in this one, we just loop between 0 to 0.5 where there is no animation. And when we remove it, we then play the remainder of the animation before the particle is removed. So I'll give you an example here. These ones do have animations that are applied, and you can see the colors constantly pulse, and they will just stay alive until we reach the maximum particle count, and then it will just play the remaining animation where it shrinks them. So you can use the particle system to create sort of cheap decal effects or all sorts of other types of artwork that you might want in your game. So I'll just show you a little bit of what that looks like. So if we just go in here. So hopefully you can see this, but down here we have this new mode called ring buffer mode. So we have pause until replaced and loop until replaced. When you have loop until replaced on, you get this new property called fade time. And this is that little bit of time that it will constantly loop between. So if you want, for here we're just doing a pulsing of color, and that's between 0 and 0.7. And then at 0.7 to 1, which you can hopefully see here, we just make it shrink. So that's how our transition out. So on to the next feature. During the transition from the legacy particle system to the current one, we wanted to make sure that we completely matched all the features so that you could match your effects in the legacy with the new system. And the final effect that we were missing was a mode called systematic. Systematic lets you provide mesh data as a guide of where to spawn particles, and it will use the vertex. So it will spawn particles in order of the vertices in the mesh data. So for example, we just have a very simple shape and it just spawns them in order. But with that, you can now start to create more interesting effects. So for example, you can create the appearance of movement, as if the particles are moving along a spline. And you can also loop and ping pong. So we've taken the systematic approach that was in Legacy, and we've also kind of improved it with the introduction of what we call edge mode. So with edge mode, we will take the vertices and we will generate points in between, so you can create a nice seamless transition. So for example here, we've got some mesh data for text and for the unity shape, and we're just spawning particles along it, and we're combining it with the ring buffer mode so that it creates the appearance of movement, and then we just got a bit of noise at the end, so as the particles fade out. And then you can create some nice effects with the shape mode, such as this one. So here we're doing the same thing again, but we're using sub-emitters. So as each particle is spawned along the vertex, we spawn some sparks. And that allows you to, again, create this appearance that the particles are following the spline when they're not. They're just a new particle is being spawned at each point along with the ring buffer mode to remove the old ones, and that creates the illusion of movement. So that brings us to the next feature. So currently, in the external forces module, you can only use wind, and it's quite limited. So we've introduced a new component that we call the particle system force field. This is a completely new component that you can add onto game objects that will allow you to create areas of influence that will affect particles outside of the main system. So you can configure the system to be influenced by all force fields, or you can provide a list, and you can use layers as well, so you have a lot of control over what force fields will affect which systems. And there's a few different properties for these force fields. So first you can configure the shape. So you can have a simple sphere shape, a cylinder, a box, and a hemisphere as shown here. And each shape will have a different influence on it depending on the other properties. So for example, you can configure the radius, the inner radius, and the outer radius. So the outer radius is the total size of the shape. The inner radius lets you configure whether the effects will influence the center of the shape or the whole shape. So for example, here you can see the light gray area has the inner radius set, which means that it creates a dead zone where no particles are influenced by the force field. And then as they hit the shell, the effect hits them and pushes them back in. So that it lets you create sort of effects where you can keep your particles contained, or you can stop them getting inside. You can create all sorts of interesting effects. Another property is what we call the gravity, and this is where the property the force field is located. So, for example, by default we use the center of the object, and that will pull things in or push them out. And you can see here, and that's what we call the property 0, so that attracts to the center of the shape. But you can also configure it to be in between the center and the outside. So here, it's not very clear, but it's in the center of the object. So it creates a sort of shell in the middle. And at the bottom, where you set the value to 1, it now acts like the shell is the location of the force. It's almost like a shield, and it's pushing the shell, the objects back out. So as they push in, they then have their velocity affected by the force, which will pull them out. So once you combine all of these features, you can create nice effects like this. So here we've got 2 force fields, which I'll show you how this is put together. So we've got our fan, which has a force field in it. There we go. So you can see we're using a cylinder force field here, and that's applying a vortex effect. That makes our particles start to spin. And you can change all of these properties whilst it's running, so you can animate them, you can use the script to control them, you can turn them on and off. So now you can see they're just moving in a line, they're no longer affected by the vortex. And we have another one, a sphere here. That's acting as our sort of gravity well, pulling in the shapes. And you can turn that off, and now they're all just free. And this down here is our new component, so particle system force field. So you can see you can also use the min-max curves, so you can use a curve over time. You can configure the other parameters. There's quite a few parameters. You can also provide a volume texture, so you can get some really interesting effects. And you can apply some drag and various other properties. Another little feature is the texture sheet animation module. We've now added support for animations that are independent of the lifetime of the particle. So you can do frame-based animations like this one. So all of these particles have an infinite lifetime, but we're using a frame-based effect, so you'll just keep them on. So you can get some really nice effects and get some better performance if you're using a 2D game, for example, and you just want to have fire effects in the background. You can also have it pick a frame based on the speed of the particle. Make it bigger. And just some brief extras as well to talk about. So the min-max curve and the min-max gradient can now be used in your own scripts. So you can add these in, and it will serialize for you, and it will also have its own custom inspector. So that should help you improve your scripts a little bit. We've also added what's called bake mesh support. So we've added this both to particle system, line renderer, and trail renderer. The particle team is actually responsible for the lines and the trails as well. So they all come under the same team. So with bake mesh support, you can get a mesh object back from the particles or the trails or the lines. And you can use this to, say, for example, apply some other effects or use collisions. If you want to get some collisions on your line, you can use a mesh collider along with bake mesh support. We've also improved the editor for the line renderer. So you can now edit the lines in the scene. So for example, you can grab the points, drag them along. You can create new points. You can also apply line simplification to it. So if you have a very complex line, and you can also just draw lines in the world. And the simplify algorithm is available in script, so if you want to use that for non-lines, your own code. And this is a bit about performance. So we have what's called automatic culling enabled. So in last year and the year before, we talked a little bit about what we call procedural mode in particles. So you may have seen at Unite Europe or a blog post we wrote. But internally, inside the particle system, we have what's called two modes, procedural and non-procedural. So in procedural mode, the particle system is deterministic. You can predict at any point in time what its state will be in. So where the particles will be, what colors they will be, the size, the shape. And this means that when the system is no longer on the screen, we can still update, we don't need to update it. So we can cull the system so that it saves on performance. And then when it comes back on screen, we know exactly what point in time we need to put the system to. However, there's some properties and modules that break what we call procedural mode. And when this happens, the system is no longer deterministic, so we have to continue to update the system, even though it's not on screen. And when you have a lot of systems in the world, this can be a big performance hit. So for example, collisions, trails, world space particles, all of these will break your what we call procedural mode or your automatic culling. Or if you have a script that is modifying a particle system at runtime, that will also break it, even though it's changing a property that is considered deterministic normally. So we have this new property called automatic culling enabled that lets you check what mode it's in at runtime. And with this, you can apply what we call custom culling. So last year, we showed an example of this custom culling, and it actually had a bug in it. So we've improved on that now, so you can get much better performance. So I'll give you an example. Here we've got a scene with a lot of particle systems in it. 460 at the moment, and you can see these are non-procedural systems because we're using trails, collisions, and world space. And you can see it's running really slow. So what I can do is enable our custom culling. There we go. And you can see you get a significant improvement on performance whilst there is no visual difference. And now we can see that there's actually only about 48 systems on at the moment. So let's have a little look at what's going on. Okay. So here's one of our effects. So if you want to see if your effect supports automatic culling or procedural mode, there's a little icon at the top here, this little white icon. If you hover your mouse over it, you'll get a tooltip telling you why it's broken. So for example, in this one, we're using the noise module, we're using collisions, sub-emitters, and trails, and all of those will break the procedural mode. Which means that when this system is no longer on the screen, it's still going to be updated as if it was being drawn still. But this effect is quite limited. It's in a small localized area. It doesn't need to be continuously updated. So it is safe for us to cull it manually. So here's our script. So the first thing we have is what's called the culling group. And that's a component that lets you hook into the culling system for Unity. And you can use that for anything. It doesn't have to be particles. We're just going to use it. And one important thing to remember, that was our original bug, is that the culling group, when you first create it, it doesn't indicate what its culling state is until its state changes. So you need to make sure you synchronize your particles with the culling group when you first create it. Otherwise, they will be in different states. And generally, the state the particle system starts in is not culled, and the culling group starts in a culled state. So you won't get any performance benefits until the particle has been on screen and then off screen to get its state changed events. So as you can see here, we now cull it. We now synchronize the state. and then you get this little event, which will then tell you when the state has changed. And all we do when we call a particle system is we pause it, because when it's paused, it doesn't need to continue to update itself, so that will help a lot on some performance. And we also disable its renderer. And to do that, all you need to do is just call get component on its for particle system renderer and just disable it, as we do here. And then when the system comes back on, you just do the reverse and re-enable it and press play or call play. And that will then let the system resume. What you could do as well is, if you wanted to make it appear that the system is still running and you don't want it to be obvious that you've paused it, you could also call simulate to fast forward it a little bit, just so it doesn't look exactly the same as it was when it went off screen. And so we have that script on here. And you can see we've got a little culling sphere. Okay. So just to summarize, you can now check the automatic culling enabled property in the particle system to see if you do need to do any custom culling. So if you want to write some intelligent scripts that will only apply culling if you need to, or if you want to know how many systems are in your world currently that might be hurting your performance, you can start to use this property. Previously, there was no way to know outside of the editor other than looking at the bounds and seeing if they were dynamically changing. When you do use custom culling, make sure that you synchronize, so start in a culled state. And to do that, just check the property on the custom bounds to see what it is to make sure you're both in the same state. If you do make any changes with a script to a particle system at runtime, that will automatically break your culling support. So if you want to re-enable that culling support, you can reset the system by calling stop and clear. Or you can just call stop with the clear flag as well, and that will do the same thing. And that will reset it back into a culling enabled state, if possible. When you do want to cull the system, make sure you pause it to reduce the CPU usage and disable any renderers. That should help your culling. And you can also get hold of that script at this URL at the bottom, and it's also on the forum. So if you have any feedback, you can contact us through there. So finally, we're going to talk about a new feature we started on. We've started adding support for the C# job system. So currently, if you're writing a script and you want to modify particles, the only way you can do that is to call getParticles, which will copy all of the particle data over to your script. You can then apply some changes to it, usually on the main thread. And then you'd call setParticles, which will copy all that data back. And that can be quite costly when you're dealing with a lot of systems and a lot of data. So with the new C# job system, we can now provide direct access to the particle system. So you can now write and read to its particle data without any copying. And you can also run multi-threaded, so you can get a lot more performance. And this allows the concept of user-made particle modules. So you can now create your own module and just put it onto the particle system, and it will almost be like its own module. You can configure it and apply the properties, and you can have multiple modules. So here's an example. We've got a simple effect that's using the mouse cursor to draw particles towards it. And we're just using the get and set particles approach. And you can see there's quite a lot of particles, and it starts to run a little bit slow. So what we can do is we can now enable our new job system support. And you see we almost double the frame rate there. And it's only a small amount of code. If you've worked with the job system, you should be familiar with it. It's very similar. Just for this one, we just took the same code and just put it into the jobs. And that actually brings us to the end. That was a bit quick. Thank you for your time.